very excited to be sharing my work with the H2H8 community today. So my project is called For Exposure to PM2.5 from California's on-road mobile sources, relative disparities by race ethnicity remain even after decades of emissions controls. And the preprint, if anyone's interested, is available at that QR code. So I want to start by just acknowledging my co-authors of this project and our funding. So I've had the wonderful pleasure of working with members of the California Office of Environmental Health Hazard Assessment, which is a branch of the California EPA. I've also had support from the University of Washington, as well as my PI here on campus. And we've been really lucky to have funding from Cal who I was just talking about, as well as H2H8 and the University of California, Berkeley. We've also had support. One of our fundamental emissions data sets comes from the California Air Resources Board, which is another branch of Cal EPA, as well as just the modeling and air quality communities that I'm a part of. So lots of thank you. Takes a village. So I want to start by just motivating this work by saying that ambient fine particulate matter, or as I'm going to call it from here on forward, PM2.5, is a key environmental risk factor for premature mortality. Worldwide, it's the #1 environmental risk factor for premature mortality. But I'm going to be focusing on California, so I came up with this figure from the Global Burden of Disease just for California-specific mortality. And if you look at all of the causes or all of the risk factors that lead to people dying, air pollution, I have a little box, comes up actually relatively high for the level of pollution that we have in our environment. So just to contextualize it, because I know the font is a little bit small, it's just below drug use, for example, as a risk factor for premature mortality in California. And it's estimated to contribute to about 7,700 excess deaths, which is pretty high, again, for relatively low levels. But the exposure to PM2.5 in California is not equally distributed amongst all of the residents of our state. In fact, in the United States and in California, people of color are disproportionately exposed to PM2.5, and that PM2.5 is coming from a variety of sources. In the US, we find that Black Americans in particular are disproportionately exposed to emissions from every single source category. And in California, we find that race ethnicity is a very strong indicator of overexposure, which is what I'm showing here on the right. So there's this growing movement in the air pollution space to think more about environmental justice and environmental equity. And this is kind of happening at the same time that there are lots of discussions about a different set of co-benefits that you can have. So because sources that emit air pollutants also emit climate forcers, there's a lot of discussion about what kinds of policies we can create that have these co-benefits. So in this little axis that I've drawn here, you can think of health as sort of like environmental health from air pollution, so that kind of excess mortality that I was just talking about, versus a climate benefit would be something that reduces greenhouse gases and helps us mitigate climate change. And just to give you a couple examples of the things that I'm talking about in this co-benefit space, if you think about tailpipe controls, like installing a filter on the back of a truck, that's going to have great benefits for health, but not necessarily mitigate any of our climate forces. At the same time, if everybody switched to a plant-based diet, it would be really good for climate mitigation, but not that great for air pollution health. And just to give two more examples that are kind of in that in-between space, you have vehicle electrification, which cuts greenhouse gases and air pollution, and same thing with renewable electricity. But tying all these ideas together, there's this idea that, well, potentially there could be this third axis of co-benefits along the equity and environmental justice space. And so that's sort of the background here, is that is it actually possible to have this policy triple win? We're not the first to come up with this question. In fact, a paper that came out last summer did a very similar future modeling study where they looked at a couple of different climate policies and they tried to compare the benefits of these climate mitigation strategies across air quality, climate, and equity. And what they found is that it was great for, it was a win for health, win for climate, but didn't really win on equity. And in fact, we saw that the disparity between racial and ethnic minorities actually increased as a function of an increased climate mitigation. So yeah, there's very limited equity benefit in this climate scenario. So it leaves the question, how do we achieve all three? Is it possible? And there are two schools of thought in the field about how you could potentially do this. The first is this idea that if we keep regulating things by sector, the way that US environmental policy has always been done, so we mitigate our power plants, and then we mitigate our vehicles, and then we mitigate our agriculture, et cetera. There's literature that shows that this is This will get us there eventually, but it's probably not a very efficient way to do it. So this is an optimization study that was done. That shows that if we go sector by sector, we'll eventually get there, but if we actually target specific locations, we'll get there a lot faster. On the contrary, there are other studies that show that there are specific sectors that are these like high priority sectors to mitigate because they have really high disparity mitigation potential. So what this paper found is that if we focus on the transportation sector, for example, there's a lot of potential to mitigate disparity because it's one of the more disparate source sectors. So all of the work that's been done thus far has sort of projected these emissions into the future or done these optimization models, and we were curious in our study what we can learn by looking back at policy that has already happened. So we're better than to look in California. California's been the global leader of mobile source emissions controls. So this is a picture of California in 1948. This is the LA area, and it was famous for its super, super snoggy days that were tied pretty directly to the transportation sector, amongst other things. The transportation sector in particular was a big polluter in that time. And since then, California has been really the US's leader in on-road mobile emission source controls. And even just in recent years, if you look at the emissions of PM2.5 and then 3 precursor species that create PM2.5 downwind, we find that emissions are going down pretty much across the board, with a little exception of our friend ammonia over here, but overall it is still trending very much down, meaning that in just the last 20 years even, we've had some pretty substantial reductions in emissions across a lot of vehicle fleets. So that leads us with this question, just tying all of this together. If we know we're starting from a place where racist policies like redlining and highway location and all of these things have led to disparate exposures in the past, what has this policy done? Has it led to something that is more environmentally just or less environmentally just? So very briefly, to do this work, we developed a novel modeling pipeline to estimate exposure disparities. So we took emissions of on-road mobile sources from the California State Regulatory Emissions Model called MFAC, and they give it to us in 50-something different vehicle classes across different fuel types. We bin that into 4 different vehicle categories: light duty, medium duty, heavy duty, and all other vehicles, things like buses, motorcycles, etc. We run it through EchoAir, which is a novel pipeline that we've developed. It's sort of like a wrapper around the in-map source receptor matrix, which is a reduced complexity model that has been validated in the literature. And then from those concentration fields, we can couple that with census population data, and we're able to estimate exposure and disparity across different racial ethnic groups. So with that, I just want to go through some of the key findings of our paper. It's sort of a high level. And the first one is that just thinking back to that triple axis, from a health perspective, California's on-road mobile source policy has been a tremendous victory. So what I'm showing here is the population-weighted mean exposure to PM2.5 across all groups from 2000 to 2019. And what we find is that across the board, everybody's exposure is going down. At the statewide average level, it's going down by about 65%, which is fantastic. That is absolutely a victory for public health. At the same time, however, if we focus in on the different racial ethnic groups that we're studying here, and we calculate the relative disparity in exposure, which you can think of as sort of a percent difference between a group's exposure and the state average exposure, we see that there's relatively little difference at the start of our two-decade study to the end of it. So just to kind of add a bit more context here, if this was a perfectly environmentally just policy, we would see that all of these lines would converge around 0, I guess this way. But in fact, they're actually relatively flat, if not slightly increasing. So from an equity perspective, this policy has left just a little bit to be desired at a statewide mean level. But it's not just the statewide mean that matters. When we talk about environmental equity, it's really important to focus on what's happening at the extremes. So think like the most polluted spaces and the least polluted spaces. And so the way that we do that is we break up the concentration that we model into the lowest 10th percentile across time, and then the highest 10th percentile, so like the most polluted environments across the 2 decades. And we break up who lives in those grid cells by their race ethnicity, and compare that against the California state demographics that we use here. This is for the 2010 census. And what we find is that across time, and these might look like stacked bar plots, but they are actually stacked time series, Hispanic Californians are overrepresented in the most polluted grid cells, whereas white Californians are overrepresented in the cleanest decile of grid cells. So overall, what we're finding is that at the extremes, these disparities are virtually unchanged. So even though pollution got better for everyone, the pollution, we haven't seen we're still seeing these sustained disparities in the most polluted environments. So going back to that sector versus location approach, we also wanted to pick apart which specific vehicles are contributing to disparities and how. So for the next couple slides, I'm going to focus in on just the Hispanic Californians because they're the most exposed group at the statewide average. And so what we do here is we take the absolute disparity to PM2.5, which is the concentration that Hispanic Californians are exposed to minus the statewide average concentration. And we decompose that into the individual vehicles that are contributing to that. And then when we normalize that to the total absolute disparity to get this fractional contribution, we find that light-duty vehicles are responsible for 60 to 70% of the absolute disparity to Hispanic Californians. And I'm just showing Hispanic Californians here, but we actually found that this trend is very consistent across Black Californians, Asian Californians, and members of disadvantaged communities. And so this goes a little bit in contrast to a little bit of the conventional thought that really focuses in on heavy-duty vehicles as being really important for environmental justice. And that's where I kind of want to pivot here to another way to think about contributions to disparity, which is not who's contributing the most micrograms per cubic meter of PM2.5 for a community, but which fleets are disproportionately affecting communities. So here we kind of flip that metric on its head and say if we just compare how heavy-duty vehicles, for example, impact Hispanic Californians versus how heavy-duty vehicles impact the statewide population, we see that heavy-duty vehicles are the largest, are the most disparate exposing fleet. So kind of the way to think about this all in all is that while light-duty vehicles are contributing the most exposure, which makes sense, they're all over the place, they drive by your house, they're in your communities, they're everywhere, right? And they're emitting a lot. Heavy-duty vehicles have the highest relative disparity because Hispanic Californians disproportionately live closer to avenues that heavy-duty vehicles are driving. So now I kind of want to zoom out again and talk about another way that we can think about environmental justice, which is that it's kind of a problem of scales. And so again, if we're thinking about the sector versus location, what if we did a sector and location analysis here? So we're going to do a little exercise. So this is a pie chart representing that the contribution to the absolute disparity, or just the statewide population. This is the contribution to exposure. And you can see that 61% is consistent with what we saw before. But I want to just zoom in on two different regions and two different California politically designated disadvantaged communities. And we'll start with our local community here in the San Francisco Bay Area. We'll zoom in on West Oakland, which is an AB 617, which is the statutory designation, but it's a disadvantaged community right here in our backyard. We'll also look over here in the Central Valley, which is the middle part of the state, and we'll look at one of their AB 617 communities, Arvin, Vermont. What I really want us to focus in on is the difference in the contribution from heavy-duty vehicles. And here, it's really, really clear that that 22% is not representative of everywhere, right? It's just at the statewide average. And in fact, a completely different approach is warranted for a community like West Oakland versus a community like Arvin, Vermont. And we repeat this analysis in the paper across all 19 disadvantaged communities in the state. And what we find is that there is really substantial spatial heterogeneity. And it really drives home the point that community-specific analyses are necessary for doing this kind of intervention. So with that, I have a couple of key insights for future policy and a little bit of a call to action. So the first is that spatial disparities in exposure will persist unless we significantly alter where emissions are happening. And to say that slightly differently, we can't just fix the exposure disparity by ramping down emissions altogether. It's really important that instead we prioritize and target these communities that are overburdened instead of just relying on the co-benefit model. And that, if we kind of flip this model on its head by targeting the environmental justice specifically and prioritizing that, we'll still get climate mitigation and overall public health benefit, but the opposite is not necessarily true. That's all I have, so thank you so much for your attention. happy to take questions.